This presentation is a simulation for the excitation characteristic of a DC generator using multi-sim. So the objectives of the simulation are to record the excitation characteristic of a DC generator. Secondly, to plot the excitation current versus the output voltage of a generator or a DC generator. So, a typical DC generator system consists of two major components. One is the prime mover, and secondly, the generator itself or the dynamo. The term dynamo is a general term for direct current machines. So when dynamo is given with mechanical input, then the dynamo is termed as a DC generator. But when dynamo is given with an electrical input, then the dynamo is termed as DC motor. So the purpose of the prime mover is to produce mechanical energy. Okay, so that is being used to move or to rotate the armature conductors in a DC generator. So once the mechanical energy is present, when a DC generator is added with an excitation, or basically the generator is added with magnetism, then the generator or the DC generator will be able to build up uh, voltage, and in turn uh, will have an output of electrical energy. So the setup is being explained by Michael Faraday. So according to Michael Faraday, that when you have their uh, conductor, and then the conductor is being moved across a magnetic line of force, and then when the conductor cuts the magnetic lines of force, then the conductor will be able to produce or induce voltage. So similarly, in a DC generator setup, the prime mover, so which produces mechanical energy, is actually the one that causes the armature conductors in the generator system to move or to rotate across the source of the magnetism, or across the magnet or magnetism, which can be found in the periphery of the generator body. So once this conductor cuts the magnetic flux or the magnetic lines of force, then uh, these conductors will be able to induce voltage, and in turn the generator will be able to produce electrical energy. So this will be the circuit diagram that will be built using the multi-sim software. So what we have in the left side is actually the prime mover given by the DC motor. So the DC motor will provide the mechanical energy that is being given as an input to the DC generator. So the source of magnetism is actually given by the field winding, so which is actually supplied by a separate DC source. So depending on the source of the magnetism, the DC generator can be termed as separately excited if it is or if the field winding is being given by a separate source, and then if the field winding is excited by uh, the generator's output voltage, then the said generator is termed as self-excited generator. Now, for the purpose of the experiment using the multi-sim software, so we'll be using the separately excited generator. So in order for us to identify so what would be the relationship between the excitation current and to the output voltage of a given DC generator. So assuming that you have already installed the multi-sim software, so your first task is to open the software. Okay, so you'll be prompted with uh, this tab. So initially, upon your first installation, the validity of the software is only for 7 days, but you can extend the validity of the um, student version of the software by creating an account with the national instrument. So you can access the account, or you can access um, the website of national instruments via internet. So what we need to do now is to launch the multi-sim. So we're using multi-sim 14.1. Okay, so then you'll be directed to this window. Okay, so this would be the working environment in a multi-sim software. Okay, so for simplicity, we'll just follow so the given equivalent circuit. So if you do not have this working area in multi-sim, so you can create one by clicking this tab new, or you can use Control N, and then you'll be directed to a working area similar to this one. Okay, so first thing is to create the circuit for the prime mover, so which is the DC generator, I mean DC motor. So we have here the DC voltage for the DC motor. So you may find the DC voltage. So by clicking this tab, place source, click this one, and then click power sources, then create or click DC power and click OK. Okay, you may put the DC source anywhere in the working area. So just click, and then uh, after clicking, you'll be directed to the same tab. So you may close this tab. So click close, and then you may edit the applied voltage. So we'll have 100 volts for the applied voltage in the motor. And then the next one is the potentiometer. So for the potentiometer, so we click the place basic. Okay, so and then look for, so under basic tab, so you look for the potentiometer. Okay, so you may click the 1000 ohm full value. So that means the maximum value of the potentiometer is 1000 ohms, and then the minimum value of the potentiometer is 0. So just click OK. Okay, so you can click the potentiometer here. Okay, then click close. Okay, so you can rotate this potentiometer. So you may click, or you may right click and then rotate 90 uh, degrees clockwise. Okay, so you can move it, or you can adjust the position of the potentiometer. Okay, so the next one is the DC motor. So the DC motor can be found in the place basic tab. Okay, so and then um, you go to rated virtual, click rated virtual, and then click motor rated and click OK. Okay, so you have there the circuit for, okay, then click close, then you have there the circuit for the, okay, so the circuit for the prime mover of the DC generator system. So to connect, so you just need to click one end of the voltage source, and then you drag it down to one end of the potentiometer, click, and then it automatically connects the end of the potentiometer to the end of the voltage source. Then the adjustable point of the potentiometer will be connected to the field winding of the motor. So again, you just need to click, okay, click, and then you move it until to the next terminal point, and then click, and then it will automatically connect. Okay, so and then the negative terminal of the DC source will be connected to one end of the um, field winding of the DC motor. Click, and then you may adjust, okay, so the position of the uh, connecting conductor. So you may move it downward, okay, just like this one, and then it automatically adjusts um, its position. So the next one is to connect the armature terminals of the DC motor. So one end will be connected to the positive terminal. Okay, so you may, for example, you connect it directly to the positive terminal. Okay, so here, so you may adjust the position of the um, connecting conductor. Okay, and then the one end of the armature terminal is connected to the negative. So we may connect it here. Okay, so just click and then it automatically connect. Okay, so there is still one component lacking, which is the ground. So the ground is very important in multi-sim, because once you omit the ground, so it will cause error during the simulation. Okay, so we try to click um, this one. Okay, so try to click place source and then click ground. Okay, so this can be found under sources, then click ground. Okay, and then you may place it below and then click close, and then you can connect the ground to any part of the circuit connecting to the negative terminal, for example here. Okay, so just click, and then if you want to move the position of the grounding connection, then you can click and then move it here. Okay, so then you have there the circuit for the prime mover of the DC generator system. Okay, so we need to adjust the field winding resistance. So from the diagram, it is set to 10%. Okay, so you just need to move the cursor of your mouse near the potentiometer, and then um, the percentage tapping will pop out. So you can adjust the value of the field winding resistance to 10%. Okay, so the next one is the setup for the generator. Okay, so for the generator, so we can have the generator from this tab. Okay, so place electromechanical. You click it. Okay, and then click machines. Okay, then uh, DC machine wound field, not the DC machine permanent magnet. So the wound field is actually supplied with an electromagnet, so wherein we can adjust the strength of the magnetism. So unlike with the permanent magnet, that we cannot adjust the strength of the magnetism coming from a permanent magnet. However, for an electromagnet, we can adjust the excitation uh, current to adjust the strength of the field magnet. Click. So click OK, and then you will have there the um, DC generator. Okay, so then you may put it anywhere in the working area. Okay, so click. Okay, and then close. Okay, so perhaps we need to use the full screen. Okay, so you can adjust, by the way, the um, okay, so you can adjust the size uh, of the components in your screen by, okay, so if you have the mouse, you can use the scroll. Okay, so you can uh, or you can use this button here, okay, to zoom in and zoom out. So depending on your preference. Okay, so okay. So for the DC generator, we need to connect the shaft of the DC generator, okay, to the shaft of the DC motor or the prime mover. Okay, so we need to flip this one. Okay, so that it will act as a DC generator. So we right click or we click. Okay, so just right click and then you may choose flip horizontally. Okay, so this time, okay, so the shaft of the DC motor, I mean DC generator, is now facing to the shaft of the prime mover. So what you need to do next is to, okay, so we need to connect the shaft of the two machines. Okay, so you may click the shaft of the DC motor and then connect it to the shaft of the DC generator. Okay, so you may click now. So it is now connected. So just never mind the motor rated. So this is the name of the DC motor built, actually a built-in name of the DC motor in multi-sim. So although you can move it upward, okay, so just like that, okay, or you may leave it as is. Okay, so now for the uh, DC generator, so we have actually two parts. So the armature and then the field. So the armature is the part of the generator wherein the conductors are being wound, and then the field winding, so it's the part of the generator that generates magnetism. So so since we're using electromagnet, so we need to have a source for the field winding of the DC generator. Again, we'll be using the separately excited DC generator in this activity. Okay, so to have the DC source for the field winding, so you click place source, okay, and then click DC power. Okay, so or you may click power source. Okay, so let's try to do it again. So click place source, power source, and then DC power, and then okay. Okay, then you have there close. Okay, so you can adjust the value of this to 100 volts. Okay, so okay, then okay, so if we try to look at, okay, so from the given circuit, okay, so the DC source is being connected to a potentiometer R2. So the purpose of the potentiometer is to vary the field current that will flow, okay, so in the field winding, and then to measure the field current, so we can use the DC ammeter. Okay, so we have the DC ammeter. Okay, so first is we need to have the potentiometer. Okay, so click uh, place basic, and then okay, so click potentiometer, and then okay, so you may put it anywhere in the working area. Okay, so then click close, and then uh, so we can change the position of the potentiometer. So we can have the horizontal position of this potentiometer by clicking or right clicking the potentiometer, and then rotate it by 90 degrees clockwise. Okay, so and then okay, so we then connect. Okay, so by the way, we need to have the ammeter. Okay, so for us to identify the value of the current. Okay, so to find the ammeter, so you can click this tab here, multimeter. So click it, and then okay, so place it anywhere in the working area. Okay, then to make this one as an ammeter, so you double click and then click A. So this stands for ampere, and then the straight line, so which is actually for direct current. And then you may close the meter. Okay, so the positive supply must be connected to the positive terminal of the ammeter. So if you mistakenly connect this one to the negative terminal of the ammeter, your ammeter will read a negative value. Okay, so in order to avoid um, lines crossing with each other, so we can flip the ammeter, so to have the positive side or positive terminal in this side. Okay, so we can right click, flip horizontally, and then uh, we connect the positive terminal of the source to the ammeter. Okay, so you need to just drag the terminal going to the next terminal point. Okay, so the negative terminal will be connected to the potentiometer. Okay, so and then click. Okay, okay, so we have the wrong connection, so we can delete this one. So just right click and then delete. Okay, so we can have it here. Click. Okay, so you can adjust the position of the ammeter. Okay, so and then so this terminal, okay, so will be connected to one end of the field winding. Okay, so and then the negative terminal will be connected to the other end of the field winding. Okay, so you may okay, so before we move to the next part, so let's try to adjust the position of the okay, so diagram. So you may select all. Okay, and then you move it downwards. Okay, Okay, so there you have the, okay, the circuit for the field winding. So it is in the armature. Okay, so by the way, the black uh, colored part of the generator, so this one and this one actually represents the commutator. Okay, so no, not the commutator, but the carbon brush. So the periphery, so this one, so the circular periphery represents the commutator of the armature in a given generator, DC generator. Okay, so it is in the brush that the voltage will be collected. Okay, so now to measure the voltage produced by the generator terminals, so we can make use of the voltmeter. Okay, so we have the voltmeter. Okay, so this would be set as a DC voltmeter. So you double click. Okay, so click V and then the straight line. So for the meter to measure DC voltage. Okay, so we can flip this one. Okay, so I mean rotate. Okay, so such that the output, okay, so the output of the, okay, the output of the armature terminals will be connected to the voltmeter. Okay, so in this part, just click. Okay, then you can adjust the position of the connecting uh, conductors. Okay, so adjust it here. Okay, so you have, okay, so and then the negative terminal will be connected to, okay, so the other end of the carbon brush. Okay, so you can adjust it here. Okay, then you have now the complete set of the uh, DC generator system. Okay, so the ammeter. Okay, so the ammeter will be used to measure the field current, and then the voltmeter will be used to measure the output voltage of the generator. Okay, so okay, so the next one, okay, the next thing to do is to set the parameters of the motor and generator. Okay, so as given. Okay, so we try to look at the parameters of the motor and generator. Okay, so for the motor, okay, so for the prime mover, so the parameters must be set to. So you have there, okay, so how to set the parameters? Okay, so you double click this motor rated, okay, and see to it that you have the same parameters as with the given. So animation factor 5. So you change the armature voltage to 200. Okay, so maximum 200. Okay, 8.8. And then maximum armature current, that's 200. Rated voltage, that's 200. Okay, so maximum field voltage, that's 200. Armature resistance, it's 1.1. Okay, so, and I think, okay, the rated speed, okay, so of the motor is set to be 1500 RPM. Okay, so click OK, and then for the generator, okay, so we have here the parameters of the generator. Okay, so you double click the generator, change to the following. Okay, so we have their armature inductance, armature resistance. Okay, so field winding inductance, field winding resistance. So armature field mutual inductance to be changed to 500 milli. Okay, so inertia and everything. Okay, so are already okay. So click OK. Okay, then you have there the okay the setting of the machines. Okay, so next thing is to display. Okay, so the current. Okay, so read by the ammeter. So we just need to double click this one. Okay, and then for meter 2, so double click. Okay, and then you have there the uh, current and then the voltage display. So next is to run the circuit. Okay, so you may click this button or press F5. Okay, so upon clicking this one, okay, so you see that the motor now is already running. Okay, so and then the current flowing in the field winding is 100 or almost 200 milliampere. So it causes the generator to produce 256 volts. Okay, so if we try to look at the table, okay, so for our data and results, okay, okay, so in this table, okay, so we need to have the reading. Okay, so for the field current with respect to the value of the field resistance in terms of percentage. Okay, so we start with 100%, so going to 90 and up to 20%. Okay, and then we need to record the value of IF and the terminal voltage. Okay, so first is RF to be set to 100%. That means R2 here must be set to 1000 ohms. Okay, so again, you just need to put the cursor of your mouse near to R2. Okay, and then the percentage tapping will be displayed. So you can adjust this one to 100%, and you notice that, okay, so the reading of the meter also changes. Okay, so the field current. Okay, so when RF is okay 100% or 1000 ohms, so that this is 99.99 milliampere. So the terminal voltage is 128.184. Okay, so unit in volts. Okay, so we adjust it to 90%. Okay, so 90%. Okay, so 90%. Okay, so you notice that the excitation current increases. 0.099. So unit in milliampere. The corresponding voltage to be 142.426 volts. Okay, so and then uh, for this activity, you will be tasked to obtain the readings. Okay, so for the field current and the terminal voltage, as we try to decrease the value of the tapping. Okay, so for RF, okay, so you record the values, no? So for the field current and the terminal voltage of the generator. So as of this time, never mind what happens to the motor. So we just focused our attention to the field. Okay, so the field current with respect to the output voltage is of the generator. Okay, so you need to complete this task. Okay, so from 80% to 20%. So you write all the data. Okay, so in this table. Okay, so this will serve as your data and results for experiment number 1. Okay, so